Okay, guys, you should have out worksheet 11 through 15, the pink sheet, and the 4.4 bookwork. I will be going over questions, but first, there's a couple basic things I want to go over. The first one is this. This is actually question 23B, maybe? Anybody tell me what worksheet that's on? Thank you. But I'm not going to actually necessarily do what the directions say for that question. I just want to work on the difference between what is write the factors and find the zeros. Because those will get you massive points taken off on the test tomorrow if you don't know the difference between those. Okay? Make sure my sound down. I don't know if that matters when I'm recording, but all right. The difference is, well, to start this question, first of all the rational zeros are factors of 68, but I really don't care. Graph it and find some zeros for me. That's how you would start this question. Sean, get a calculator. Anisha, get a calculator. Brennan, get a calculator. Okay. Amber said she found 2 and -2 when she graphed it. All right, those are 2 of the zeros. I don't know if there are any more real zeros. Actually, by looking at the graph, I think there aren't any more real zeros. So if all it asked you to find were the real zeros, you would write 2 and -2 and be done. If all it asked you to do were find the rational zeros that worked, you would write 2 and -2 and be done. If it said find all the zeros over the complex number system, or if it said factor, then you need to do synthetic division. Okay, when you do synthetic division, what should happen in terms of a remainder? If it doesn't come out to 0, you messed something up. Okay, if you graphed it and you found 2 was a 0. So quickly, help. Did I do something wrong already? What? Thanks. All right, so that one came out 0. What do I have to do next? If I need all the factors. This is on the test, and I have some of you who aren't paying attention. This is not a good plan, okay? I would then have to divide the -2 into this to keep factoring it. So the factors are what?
X minus 2 is plus 2. X squared. Yeah, X squared is 8x. Plus 2.
All right, if it just said factor, that does not factor any further. So you're done. If it said find all the zeros, what would you have to do to find the other 2 zeros? Okay. You would use quadratic formula. Which comes out plus or minus the square root of -4. So -8 plus or minus 2y over 2, which simplifies to what? Okay. -4 plus or minus I. Now do I have all 4 possible zeros? Okay. If it said over the complex number system, I now have all 4 of them. Also on the test is one question that says factor completely in linear factors. What's wrong with my factoring up here? That one's still a quadratic. Anybody know how to write it so it would have linear factors? Okay? I would really appreciate it if you got rid of the extra parentheses here, but it's not wrong. It's fine. X minus 2, x plus 2, x minus negative 4 plus I, and x minus negative 4 minus I. Now it's linear factors. Yes.
I have a question for the complex numbers. Is it possible that you can have a vertical asymptote that is like a
Complex? No. All right. Does that clear up a little bit the difference between factors and zeros? All right. Factors are going to have x's. Zeros are just values where it's crossing the x-axis. But I'm pretty sure at no point should you have decimal answers for zeros on this test, okay? Because it's about the rational root theorem, about complex zeros, and finding exact zeros. All right, I also wanted what does that question actually say, Gunther? Okay, so all you need to do is write down 2, negative 2, and negative 4 plus or minus I. Okay, but that's all I gotta do is write down what's in that blue circle, okay? The rest of that was extra stuff I did. All right, so on this packet, were there questions you want me to go over? Brennan?
I don't have a specific number in mind, but I still don't really understand writing the equation for the degree of the.
For the end behavior,
Yeah,
okay?
behavior.
That is step 7 on your blue sheet, which you get to use on the test. I will go through some examples, right? Here, number 12 on this sheet says describe the end behavior. The first example is equal weight. Do you understand what that means?
Yeah.
Okay. So then it's y equals leading coefficient over leading coefficient. So this one is y equals negative 1. The second example here, be careful, degree 2 and degree 2 right here. So this one is also y equals leading coefficient over leading coefficient, which would reduce to negative 1/2. What about C? It is bottom heavy. What is the rule for bottom heavy? Approaches y equals 0. D is degree 4 over degree 2. The rule is you have to divide, but you get to ignore. This one you could actually factor out some things, but I'll do it this way. You get to ignore the remainder. Was that a minus under there, guys, before I drew on top of it? Is it minus 3x to the 4th? Okay, thanks. I multiply by an x squared. X squared times x squared is x to the 4th. X squared times negative x, this is supposed to be a 3, is a negative x cubed. The rule is you are subtracting, so it becomes a negative 2x cubed. So I need to multiply by a negative 2x, because it has to multiply to become exactly negative 2x cubed. Then the negative 2x times this negative x is plus 2x. Then I subtract, which makes this 2x squared, which means I need a plus 2. And it actually has no remainder. The end behavior is exactly x squared minus 2x plus 2. If it has a remainder, you just get to ignore it anyway. It's not part of your end behavior equation. Yes. Zach.
On 14B, number 15, so it says optional rational zero columns.
Okay. I can come back to this one, but Zach's question is about worksheet 14. 14B, this one?
Yeah, number 15.
Okay. This is worksheet 14B. Everybody should be doing this. It's on the homework check. And it's a test question. How many zeros should this have? It should have 4, if you're gonna find all of them, rational, irrational, imaginary, whatever. List all the possible rational zeros. How do you do that?
You take the, all the factors of the last number,
Factors of the constant over factors of the
the leading column.
leading coefficient. So it's plus or minus 1, 3, 13, and 39 over plus or minus 1 and 2. I think there's only one question where you really have to do this, and you need to write out what that means, okay? I don't care that you write plus or minus a million times, but it means 1, 3, 13, and 39 are all possible, but also 1/2, 3 halves, 13 halves, and 39 halves are all possible rational zeros. The next thing you do is you actually graph it, okay? 2 of them work? Yes? Which 2? 3 halves and -1 both work. Okay? I'm going to do the -1 first. You need to do synthetic division. 2, -9, 27, -1, and -39. Did I get those copied down right, guys?
Yeah.
Okay. 2 times -1 is -2. -1 times -11 is +11. -1 times 38 is -38. -39 times 1 is 39, and this comes out 0. That's lovely. If it doesn't come out 0, I did something wrong, okay? If you do it and you cannot figure out what's wrong, but you know something's wrong, bring it up and I'll look at it, okay? I know how frustrating it is to go through it 3 times and go, I know it has to come out 0. It's not giving a 0. I can't find my mistake. All right. The next thing we need to do is 3 halves. It's probably easier if we do this as 1.5. And it goes into this. You don't go back to your original one. Bring down the 2. 2 times 1.5 is 3. -8 times 1.5 is -12, I think. 26 times 1.5 is 39, so this comes out 0. All right. So far, what is our factored form?
X plus 1. X minus 2 times
3 halves, yeah.
3x.
This remainder, or this business down here, represents 2x squared minus 8x plus 26. We can at least take a 2 out of that, though? Okay, does that factor any further? Not nicely. If it's said right as linear factors, you're not done. But if all it says is write in factored form, which this one does, this is the answer. You do need to make sure you have the same leading coefficient, because remember, the whole point in factoring is that if you were to multiply it all back together, it has to go back to what you started with. Okay? That's why we learn foiling before we factor, right? So it's got to go both ways. Find the exact value of the remaining zeros would mean do quadratic formula on this x squared minus 4x plus 13. You could do it on the 2x squared minus 8x plus 26. You get the same answer, it's just bigger numbers. If I remember right, is that -36? Anybody helping me out here? So the other zeros are at 2 plus 3i and 2 minus 3i, which you can write as plus or minus, it's fine, but Okay? Yes, no, maybe?
Number 12B.
Okay, just a second. Anybody still have a question on this problem? Gunther, you have what you want copied down or not? I can wait. You okay? All right, Sean, 12. Okay?
Number 15. So it's I squared to 47 times I, right?
Yes. Whenever it's odd, I would take out one I, and that would leave 94. Because I want an even here that divides by 2. This is 47, let's not. I squared to the 47th, yes. Negative 1 to the 47th is, so you have a negative 1 and an I, which is negative I.
And then number 18, 0.
Okay, this is the square root of negative 1 times the square root of 25 times the square root of 5, which is 5i square roots of 5. There is no plus or minus on this problem, okay? It does not say x squared equals or something. You're not square rooting an x. If you had to write it in a plus bi form and you were worried about it, I would take 5i square roots of 5. But if you want to put 0 plus so that it looks more like a plus bi, I'm fine. And actually, that's the right form, but I get anxious because if that square root goes over the I, then it's wrong. I'd like to do one on the next page real quick. This number 20 is on the test, one like this. What do we do first? Now what? Okay, and when we square root, what are we going to get? A plus or minus, because we square rooted the x squared. We're going to get an I, because there's a negative 1. 72 is 36 times 2. We still have a square root of 5 in the denominator. What? Did I lose you on something? No? All right. So I have x equals plus or minus 6i square roots of 2 over the square root of 5. What's still wrong with that? Yeah, I gotta multiply by that stupid square root of 5 over square root of 5 so that I have square root of 10 over plain old 5. Hey,
How you doing?
I'm good.
This here, can you give this to that case?
Yes, absolutely. Absolutely. Are we okay on that one, or I need to do another example like that? I can make one up. Do you want to borrow a pencil? Okay, well, there's a couple of these borrow ones. Okay, yep, I will do that one. All right. Question 21 was asked about, and there is one like this on the test, but it is extra credit. I'm going to go through it anyway. It's really good practice. We can review this Somebody might get it right on the extra credit if we review it. All right. It says a polynomial function with real coefficients that satisfy the given conditions. It is degree 3. Its zeros are not -3, comma, -2i. It's -3 minus 2i and -3. What do you know right away? -3 plus 2i, the conjugate is also a 0. This is number 21. Okay. It says you have to write a polynomial function, so we need to make this x plus 3 and x minus -3 minus 2i and x minus -3 plus 2i. Okay. Is that the answer? Okay. I might give you a half point of extra credit. You tried it. But the directions say what? Real coefficients. Are these real numbers right here if they have eyes? No. Okay. The rule is the shortcut. You can distribute. You can get rid of all the extra parentheses and play the distributing game for a half hour. Or the shortcut is you need to find the sum and the product of those two imaginary zeros. Okay? If I add those together, -2i, +2i will go away and I just get what? Nope. I'm adding. -6. Okay? The product, when I multiply those, I get -3 times -3 is 9. The 6i and -6i go away, and I have a -4i squared, which becomes 4, so I get 13. So does anybody remember the rule about how that changes into a quadratic?
Oh, x squared minus.
Why did it become plus?
Wait, what is it?
No, it's not minus. It's always the opposite of the sum, okay? It's the opposite of the sum goes here. You have to change the sign, and the product goes here. Now, it has real coefficients. I'm up to a full point of extra credit, okay? If you want 2 extra credit points, there's part of the question that says it goes through some ordered pair. What would you have to do then? Okay, find the stretch out here by plugging in 0 and 78. I think you get 39 over here, which goes in twice if I tried to make this come out nice. So the final answer that would get you 2 extra credit points. You don't have to FOIL it out all the way. That would just make me have to do extra work when I grade it.
I'm going out to get a 35 extra.
Cody, is that okay?
Yeah.
It's extra credit anyway. But the idea that if -3 minus 2i is a root, that -3 plus 2i is also a root, that's important. Alright, I would kind of like to go somewhere to talk about holes and asymptotes and stuff. Would you rather I used worksheet 14 since you don't have the answers to that one? That's not the right slides. This one. Okay, the top of 14A. How do you find vertical asymptotes? First of all, vertical asymptotes are not at -5. A vertical asymptote is an equation of a line. So it has to say x equals. It is at -5, but it has to say x equals, okay? So if I factor this, anything that makes the denominator only into a 0 becomes a vertical asymptote. So this one has 1 at x equals -5. By the way, the domain would also be x cannot equal -5. If you factor this one, all right, are there two vertical asymptotes? No, because one is a factor of both the top and the bottom, which makes it a hole or a puncture. If there is a hole there, there's not a vertical asymptote. So this only vertical asymptote is at x equals -4, but if you had to do the domain for that question, you would have had to say x cannot equal plus or minus 4. It has a hole at x equals 4, okay? But it's not what it asked. This one has none, even though the top factors, that only helps you find the zeros.
So when you say x is undefined,
Do you say none? It says there may be none. Okay, I'm gonna keep going if nobody's pouncing here. End behavior, one more time. Brennan, you asked me about this. What's the end behavior of this first one?
I equals 0.
Yes, good job. It is bottom heavy. Degree 1 over degree 2. So it is y equals 0. Oh, be very careful on number 5. I got number 5 wrong earlier.
0.
It is 0 because right in here, as on the quiz last week and on tomorrow's test, they're not necessarily in order. This is bottom heavy, so it does approach y equals 0. It has a degree 3 hiding down there on the bottom. Number 6. It is top heavy, so I have to do division, and I can do synthetic on this one. Somebody check me if I'm doing something wrong here, but I think I do remember that this was really ugly. Okay, we get to ignore this whole remainder business. So this ugly quadratic is the end behavior that this would approach out on the far left and far right. It's going to look like a parabola, except it's going to have an asymptote in it.
Are we gonna be tracking these?
Snarling at me over there, Carrie. What?
Are we gonna be tracking some of these?
I think there's only one, maybe two that you have to draw me a nice accurate graph like you did on yesterday's quiz.
I mean, in the further future.
No, just whatever we do now. Number 7 is also top heavy. You would have to do long division for that one. What do you multiply by to get 2x to become a 4x squared? So then you distribute 2x times 2x is 4x squared. 2x times 1 is 2x. Then you are subtracting. So this becomes a negative 8x. So you need a minus 4 here. There's a remainder, but we don't care. It says we get to ignore remainders. Yes, on 4.4.
Yeah, it's just something.
Wait, number 7. You couldn't use synthetic division for number 7?
No, because it's 2.
There is a way to use synthetic division, but if you do, yes, use -1/2, and what do you get in the end? You don't get 2x minus 4.
You get 4x minus. Oh, you
Okay, it messes up your answer. And there's a way around it, yes, but it's just not one more rule we need to learn. All right, I've been asked to do on 4.4 bookwork to talk about number 72. This is a graph it in your calculator question. You set y equal to, and you put parentheses around the top and the bottom. It says approximately what percentage the drug is in the person's bloodstream after 4.5 hours. You're going to put in x equals 4.5, but we need to talk about an appropriate window. It says graph in an appropriate window. Okay. If x is really t, time in hours after injection, what do you think? How long is this blood or this drug going to remain in their blood? How many hours? Can always change it, but what do you want to start with? 1 hour, you think, only? I probably would have said like a day. See if the drug remains in their system. You could go out further. It is the percentage of the drug. So what's the highest it can go? 100, except I think if I remember right, this graph says a decimal, so it actually doesn't ever go above 1. Does anybody graph it?
Yeah, it doesn't go.
Okay. It uses the decimal percent instead, like 25% would be 0.25, okay? So I don't think it ever goes above 1. So you could go like -1 to 2 this way. It's obviously going to spike and go down, right? Something. I don't know that it looks just like that, but when you inject somebody with a drug, it goes into their system quickly, but then it starts to go out as your body cleans your blood. All right? What is the horizontal asymptote? What does this tell you? What's this going to eventually do after 24 or 48 or whatever hours? Yeah, it's going to approach y equals 0. And what does that mean? The drug's going to be out of your system, right? At what time is the percentage the highest, or what, and what is the percent? So you need to find the max, okay?
What? Oh, okay. Sorry.
Okay? All right.
Sorry.
I didn't solve this one. You have to type that one in. I also don't know that that's really what the graph looks like. What? I'm going to do 73 first because that Amber asked for 72 and 73. I'm going to go very quickly on this, Amber, because it's not on the test.
Okay.
But it says you have a square box, guys. The base is a square, and you don't know the height, okay? But normally to find the volume, you would go this, and it says the volume is 1,000. Did I lose anybody yet? Length times width times height, okay? The height of this box then can be written as 1,000 over x squared. Did I lose anybody? I just solved that for h because they don't want us to use two variables, so I'm going to erase this and write 1,000 over x squared. Okay, surface area. This is what shape right over here? A rectangle, and it is x by 1,000 over x squared. How many of those rectangles are there around our box? 4. Okay. There is also a bottom that is how big? X squared. Everybody good with that? It's just a square. And the top is the same. So there's 2 of those. It says the material for the top and bottom are $3 per 100 square inch. So $3 per 100 square inch gets multiplied by the top and the bottom. And the material for the sides are $1.25 per 100 square inches. What is the length, if the length express the cost of constructing the box in terms of X? All right, we can simplify this a lot. This X will cancel one of these. This goes in here 10 times. That's 40 times 1.25, which I'm thinking is 50 or 500 or something. Somebody do that for me? Kirsten, put it that way. 1.25 times 4 times 10. Anybody?
To 50.
Okay. So there was an X left down here too. So it's 50 over X. Over here I have 3 divided by 100 times 2. X squared, that's 6 over 100 or 0.06. So it might look like that in the back of the book, not too sure. For B, you would graph it in Y1. They want to know when the cost hits $20. Okay? And the box must be at least 6 inches long, so graph it for like 6 to 20 or something. And see if you find something in there, okay? But it's got to be more than 6. So if you graph it from 0 to 20, you might see 2 intersections, or 0 to 30. I'm just guessing on the 20 part.
You wrote for the X's.
Those were my X's, 0 to 20.
Oh.
Here you want to go 0 to, I don't know, 50 or something. You just want to see where it hits 20. So, all right, again, not on the test, so I'm not going to spend more time on that one. 53. Did you factor this, Sean? Well, how did we approach any of these? The first thing we did was factor them, right? This is what the blue sheet is all about. Okay, what do you know?
Well, you have a whole like X minus 2 or F2.
Okay. Vertical asymptotes where?
0, negative 3, and 2.
Nope.
Right? No, no.
Okay, can't have both a hole and a vertical asymptote. End behavior?
Y equals bottom radius of 0.
Okay. X-intercepts?
X equals negative 3.
And that's it because this is a hole. Okay? Y-intercept would be when you go back to the original function. If you put in a 0, you can't, right? Because it's not part of the domain.
Why can't you put in the 0?
Because you get a 0 in the denominator. Okay, if it asked for the domain, which it does on the test, it would be X cannot equal 0, negative 3, or 2. Even though that is a whole, it's part of the things that it can't equal. Did someone have a question? What about the back of the pink sheet? Did anybody look at the back? Did you have a question on something, Zach?
The book looks great.
On the book, number what? 8? If you take out an X, it doesn't factor any further, so the only vertical asymptote is at X equals 0. And there are no holes.
Why is it X equals 0?
Because you took out this X right here, it would make the denominator 0. If you look on the sheet, it says vertical asymptotes are anything that makes the denominator equal to 0. And you could, I don't think this is gonna come out real. Actually, I think it does. Gross. There are also 2 more vertical asymptotes here. Because you have to solve this. I will never ask you a question like that on test, okay? But it actually has 3 vertical asymptotes. It has 1 at 0 and 2 here. I kind of just assumed that that was going to be imaginary, but it wasn't. I should have been more careful. What about the back of the pink sheet? Did anybody look at the back of the pink sheet? Brennan?
Yeah, I'm still having trouble with like number 3 on the back.
Of the pink sheet?
Yeah, pink.
Okay. I just want to make sure we're talking about the same thing. Are we out at 30 or 35? Okay, then I'm going to talk about this whole pink sheet. I can go over the whole thing in 6 minutes. I know I can. Okay. What is wrong with this graph if it's supposed to be an x to the 5th equation? Okay, can you have 4 real zeros for degree 5? Because any imaginary ones come in pairs, right? So there could be 1 real and 4 imaginary, or 3 real and 2 imaginary, but there can't be 4 real and 1 imaginary. Honestly, I would have written it has the wrong end behavior. Is not in this window because it obviously, if you have a degree 5, it should be doing something more like this, right? So you can't see the end behavior in that window. What's wrong with this window? Okay, can't see the zeros or the max or mins in that window. There's 1 min over here maybe, but yeah, not a good window. All right, I'm moving on. This one, you guys can type all these in if you want. I don't remember if there's 1 or 2 of them that work. This is degree 4, so that doesn't work. This is degree 4, degree 4. So it's one or the other of these top ones. Yeah, B negative cubic, that works. This one, though, if you multiply it together, will come out a positive, won't it? A negative times a positive cubic. So I think B is the only one that works. All right, number 3. Oh, what is the multiplicity of 2 right here? At the 0 at 2, yeah, multiplicity 2. At x equals 2 is 2. At x equals negative 2, it's 3. And x equals negative 3, it's 7. This one, anybody remember how this goes? If I cut this out and fold it up, what are the dimensions of my box? Good job, Kirsten. Keep going. Okay. And x has to be less than, well, it can't actually equal 0. If you're going 15, cutting in half, yeah, 7.5. All right. It says find the volume of at least 450, so you know your y window needs to go up past 450. So you're going to graph this in y1, and in y2 you're going to graph the line 450 and see where they intersect using this window. I think there are 2 solutions on this one. Yes, would you like to pass that out, Carrie? Thanks.
No, it's tomorrow.
It's due tomorrow.
She's just giving it to us.
But you also have a test to take, so I would like you to come in with it finished, turned in, so you can get the test done. I can come back and Gunther in a minute, but I want to talk about the rest of this. Degree 8 over degree 4. Nope. It is top heavy, so you divide. When you took an x to the 8th and divided by an x to the 4th, what would you get? Right?
8 to 11. Oh, so you subtract.
You're adding exponents, yeah. You subtract to find the degree. All right, did anybody work on the pink sheet? There's one nice zero out of this list.
It's,
And it's a long list.
yeah, 776, 7.
Okay, there's the list. Anybody find the one that works? Well, I guess I can't finish this then if no one's gonna tell me which one works. Okay? If 7/3 work, we bring down a 6. 6 times 7 is 42, divided by 3 is 14. That makes a -6, so that would be a -14. -3 times 7/3 would be -7. If we took a 6 out of this, we'd have x squared minus, I can't take a 6 out, I can take a 3, sorry. I'd have 2x squared minus 2x minus 1, which is not going to factor. So it has no other rational, just says rational. Which ones work? The only one that works is 7/3. Finish the pink sheet.
Can we go back to
Yes, I can. I will not be here after school tonight.